Hello all, welcome back. In this video, we are going to learn about concurrent force system. In the concurrent force system, as we already know, all the force should act at same common point, or line of action should be meet at same common point. So in these four topics, we could learn about concurrent force systems properties. So the resolution of force means it is just opposite to the resultant of force. What we do in the resultant force, we should take all the forces acting in a system and convert that force into a single force. So in this we do just opposite to that. Consider this x and y axis. If one force is acting, that is act like this means at some angle, it will have two components both in x and y directions. So you consider this is F force means it has two components, that is Fx and Fy. And Fx is nothing but F cos theta and Fy is F sin theta. If you take resultant for these two things means you can get the value of F. So what is the resolution of force means that a force acting at angle to x and y means it has two components, that is Fx and Fy. The value of Fx is F cos theta, the value of Fy is F sin theta. Why it's necessary means if a force acting like this means if you see that four forces are acting, we want to convert into one force, that is resultant force means we should find the resolution of force first. For this and this we need to find the resolution of force. These two forces doesn't need resolution of force because it's acting axis, so this force has only component in the x direction and this force has only component in the y directions. So we need to find the resolution of force for this two, F2 and F4. And the F2 has F2 cos theta which is acting in x, and F2 sin theta which is acting in y. You take F4, it has two components which is F4 cos theta acts in minus x, and F4 sin theta which is acting in plus y. So if you want to find the resolution means first, resultant means if x is equal to, we have three forces. This is F1 which has only in the x direction F1, and F2 has F2 cos theta. If you see the F4, it is in minus x direction, so minus F4 cos theta. Here this is theta 1 that F2 acts, so F4 is theta 2. So I'm putting theta 2 here, but F3 has zero component because it acts only in the y direction. Even if you put means this is angle 90 degree means cos 90 is 0, so we don't have to consider that. So Fy means F1 would be 0 because it has only in the x, as we know. So F2 sin theta plus F3 plus F4 sin theta 2. This is theta 1. So by this only we can find the resolution. What do we know? Resolution is root of Fx squared and Fy squared, which we already know. And the angle of this force means the resultant force means, so if a resultant force is acting in like this means this is the resultant force means the angle might be alpha means that alpha is equal to tan inverse f of y and f of x, because there are, this is the resultant force means that two fx and fy act like this, that fy if you consider in this direction means, then tan alpha is equal to Fy divided by Fx. So alpha means tan inverse f of I divided by f of x. So this is how you find the resultant of a non-concurrent force system. So for that only the resolution of force is very important. Then equilibrium of concurrent forces. If an object has multiple concurrent force acting on, that means the equilibrium condition is that f of x equal to 0, f of y is equal to 0. In concurrent forces there won't be any moment created. What is moment, that we will discuss later. But in concurrent forces, these two are important things. The summation of Fx equal to 0 and summation of Fy is equal to 0, which means force acting in the x and y direction 0. Then only it could be in equilibrium. Equilibrium means it should be a stationary. Then